Okay, I apologize for the situation. I'm currently literally inside a Starbucks because I don't have a lot of options right now. We'll get started. We might have to go a little faster than expected though. So anyway, yeah, so AP Physics class, made a short introduction when I first joined. I don't think we will have a camera on right now, but so this is going to be a course mostly just to prepare people who are taking AP Physics next year because it is pretty well known as one of the hardest APs. And this isn't gonna be like covering the entire course, obviously. That's going to be for the class itself, but this is here to just help prepare everyone, provide a basic understanding of physics and make it easier to understand a lot of the topics and concepts that will show up during the year. If anyone has any questions, please put them in chat. What grade? This is just AP Physics 1 in high school. People take at different grades depending on their level, so I can't really say one grade. This is also just like prepare people who are interested in the course. If you've already taken AP Physics 1, this isn't going to be too helpful. So yeah, as you can see on the slide, there's a CED. This is for any AP course. It provides basic overview of all the courses. Your own teacher will probably tell you this at the start of the year. It's a good idea to read through this at least once or twice before the start of the year so that you have a good idea of what you're getting into. And yeah, so this is going to be a bit of a preparation course. So there's a few basic concepts to cover before we start the course itself. And the first one is going to be a vector versus a scalar quantity. A vector, so these words you're going to hear the words magnitude and direction a lot when it comes to this. Magnitude is basically just a number value. So like 2 would be a magnitude, -8 would be a magnitude. And a direction is basically just a direction. If you can point in the direction of a specific quantity, then it's going to be a vector. And there are a few differences that come up between scalar and vector quantities, and we'll be going over a few of them today as well. And so yeah, the best way to tell them apart is to just ask, can you point an arrow at it? So temperature is just a number. That's going to be a scalar. While, for example, a force, you can, if you're pushing something, you can point in the direction you're pushing it. So that's going to be a vector. Something flying across the sky, you can point in direction it's moving. So that's also going to be a vector. We'll be getting into this a little more in depth as we discuss actual vectors and scalars that are important in physics 1. So this course is going to be for 1D. And what that basically means is just a number line or just one straight line going forwards or backwards. Those are the only 2 directions you move in. Because if you think about 2D, you can move up and down, or you can move left and right. 3D adds an extra dimension you can move by, which is just depth, like going in and out of a page. If you go backwards, you can think of 1D. In 2D, you have going up and down and left and right. If you simply take away the up and down, you're left with 1D, which is just left and right. And 1D is a lot simpler than 2D because 2D, you focus on like components going, whether you're going vertically or horizontally, and you'll have to consider angles most importantly. You don't think about 30 degrees off the horizontal. You just think, are you going forwards or backwards? So it's a good place to start for getting used to physics and all the various concepts you have to learn. And of course, because it's convenient, positive is generally considered right, negative is generally considered left. Because once again, number line is a very helpful analogy. You can quite literally just think of it as number line. You can put a particle at 1 on the number line and then move it left by 2 to reach -1. And yeah, so this is gonna be like the starting unit for most physics classes. You're gonna just start on 1D, then you're gonna go to 2D. I don't think 3D isn't a thing in AP Physics 1 outside of the odd gravitations course. You're gonna mostly just stop at 2D. And so we're gonna actually go over like the main different values in 1D. The first one is going to just be position, which refers to where you are. So this is going to be a scalar. Wait, no, this is going to be a vector, sorry. basically just a spot on the number line. Actually, I don't 100% recall whether this is a scalar or vector, but the concept itself isn't too difficult to understand. It's basically a position. I think it should be a vector because, you know, you can be 5 to the north or 5 to the southeast, but yeah, so you're going to see this represented by the variable x. The standard unit is meters. And in the 1D, it's basically just the spot on the number line. Distance, specifically distance traveled is what we're going to be looking at. And it basically just refers to how much you've moved in total. And this is just a scalar. You have traveled 8 meters today, or you have walked 5 miles for some reason. Those are both examples of distance, and they are scalars, since if you don't actually say I walked 5 meters north, that would be something else, which is displacement. And distance generally doesn't have its own standard variable. You'll see people refer to it with a d sometimes, but there's no like one variable you're going to see for all time. For displacement, however, this is denoted as change in position. This little triangle, it's the Greek letter delta, and it just means change. So delta x here, it's not triangle x, it's delta x, and that just means change in x, or change in position. So this is going to be a vector instead. You can say I have a displacement of 2 meters north, and what that doesn't mean you just move 2 meters north. If you moved like 5 meters east, 4 meters north, 5 meters west, and then 2 meters down, you would have a displacement of 2 meters north in total, while your distance would be 16 meters. So the distance is the total amount of movement you did over your entire path, while the displacement is going to be the distance from your starting point. And so what's important to note here is that displacement, because it's a vector, I'm going to go over this a little more in depth when it comes to velocity, but distance can't be negative. You can either have not moved or you have moved and your distance is positive. However, displacement, if you walk backwards, you can say you've moved -2 meters right. And that would simply mean that you moved 2 meters to the left. And that's one of the important parts about including a direction in vector quantities. So this displacement is going to be more common than distance in a lot of problems, although like random problems will ask you about distance or displacement, sometimes at random, just to like make sure you know the difference between these two. So yeah, just distance is the length of the path you travel, while displacement is your distance from the starting point. Moving on. We're going to look at speed versus velocity here now. So speed is, once again, just a scalar, and velocity is the vector version. And similar to distance displacement, velocity is far more common, and you're going to be seeing velocity as your something. Oh, no. Wait. Okay. So you're going to see velocity a lot more than speed in most questions. And that's because being able to like know which direction you're moving in is a lot more important and generally just more useful than saying you're traveling at 16 miles per hour or something. The standard unit is meters per second. A lot of times you won't have units. Physics actually does like to just throw problems where they don't tell you numbers and then instead just like have variables to represent quantities, and then you find an answer in terms of the variables. But just keep in mind the standard unit is meters per second. Knowing the units is helpful for specific, like knowing what types of units. You'll notice that it's a length unit divided by a time unit. We'll be going over that in a future day, in a later day, but yeah, just keep the units in mind. It's not the exact type of unit so much as just like it's not the exact unit so much as the type of unit it is that's going to be important in the future. But going over speed and velocity themselves, these two aren't quite as different as distance and displacement because, you know, at any moment you have a speed and the velocity is just going to be that speed with a direction, while distance and displacement cover over a period of time. This does become different when it comes to average speed versus average velocity over a certain period of time. So if you like move 2 meters forward, then 2 meters back, your displacement will be 0 since you're back at your starting point. And because your velocity, I didn't write this on the PowerPoint, but speed is basically distance over time, while velocity is displacement over time, which is going to be the biggest difference. The difference mainly comes over a period of time, as I said. So going back to moving 2 meters forward and 2 meters back, your displacement is 0. So since your displacement is 0, your velocity is also 0, but your speed is still going to be bigger than 0. Similar to distance, speed is always greater than or equal to 0, while velocity is capable of being negative. So you can have an average velocity of -2 meters per second over 3 seconds, which means you moved, 6 meters backwards. You can't say that for speed, though. And the last of these basic quantities for one-dimensional motion is going to be acceleration. And that's going to be change in velocity. So basically just change in velocity over time. As it says, we're going to talk more about this in a later slide. But the standard unit is going to be meters per second squared, or meters divided by seconds divided by seconds. And you can see it's just like velocity is the change in displacement, and we have meters divided by seconds. Acceleration is going to be meters divided by seconds again. So you're going to see a lot of parallels with the relationship between between displacement and velocity, as well as just velocity versus acceleration, because they basically are the same relationship. Each one of them is just the change in the other. So yeah, acceleration itself is going to be any change in velocity. This isn't going to be as important in one-dimensional motion, but this is absolutely crucial to know, because this is going to prevent you from making some really silly mistakes at some point. People will say deceleration to refer to slowing down, but in the world of physics, any change in velocity is going to be acceleration. So slowing down is acceleration, speeding up is acceleration. Turning sideways is also acceleration. You don't have to actually change the value of speed. You don't have to change your speed to get an acceleration. So if you turn left at a corner, right? Your speed might not have changed because you just, make a turn, but your direction of velocity has. And because direction is a part of velocity, and that changed, your velocity has changed, so therefore there was an acceleration. How to actually calculate the acceleration is going to be best covered more in depth in your actual course, because for now we're just focusing on 1D motion. And in 1D, acceleration will change your speed. There's no way around it. Which is another way 1D is just going to be convenient as a place to start. Acceleration can be easier to understand. You will have to still remember, slowing down is still acceleration. Like, just erase the notion of acceleration being speeding up in your mind. I know in like an English course, you're probably not going to say accelerate to say something slowing down, but in physics, you will have to say that. So the specific word you're going to see like describe a lot of the stuff is going to be called kinematics, which basically it's going to just be basic motion. 1D is going to be the simplest version, obviously. And this wasn't as covered in the quantity section because it's not particular to one-dimensional motion, but you're going to see t as a variable time a lot. The unit is obviously seconds. And once again, just like displacement, you're going to see a lot of delta t to refer to the change in time between two modes. So between t equals 1 second and t equals 4 seconds, you will have a delta t of 3 seconds total. And what you'll see is that if you have a constant speed, obviously distance is just speed times time, and speed times change in time, more specifically. With a simple change in speed, you're going over this. There's an equation for doing this. There's a few ways to do it. We're going to be going over graphs and how to use that to find displacement through a velocity time graph. And if you have just like a linear change in speed, like acceleration is 1 meter per second squared and velocity starts at 2 meters per second, you can generally find the distance pretty simply. But if you have like a curve of speed, like speed is x squared, then to find the distance traveled with that, you're going to have to use an integral in calculus. That's going to come up in physics C if you decide to take it after physics 1. Obviously that's outside the scope of this course though. So as far as speed goes, we're mostly going to only be considering cases where either speed is constant or it's changing at a constant rate, which in other words is constant acceleration. And of course, since speed and velocity are parallels, we're gonna have that displacement is gonna be average velocity times time, delta t. And as mentioned earlier, if you have a negative velocity, then you're gonna have a negative displacement. And what that negative displacement means is basically just the opposite of whatever direction you indicate. So negative 5 meters north is going to just be 5 meters south. And basically, if you wanted to write this in terms of actual variables, you just have delta x is equal to v times delta t. Obviously, this only holds at, constant velocities, because if you have changing velocities, you don't actually know what to substitute in for v there. We're going to look at changing speeds later on in this, in today. So, quick question, everyone, to make sure everyone's keeping up so far. So if you have a ball that rolls forwards 2 meters, then it rolls back 2 meters. What's the distance and what's the displacement? Put the answer in. Oh, I'm not used to a lot of these Zoom functions. I can probably make a poll for this in the future. Yeah, I'm not sure how polls work at the moment, so I'll just do that later. For now, just put your answer in chat, and yeah, you can discuss it if you want to. I'll give it a couple minutes in case people want to put their answers in chat, but yeah. Right, good. Looks like everyone's getting it so far. Yeah, so as everyone has said so far, your distance traveled is going to be 4 meters since, you have rolled a total of 4 meters. You just add the values of the distances traveled for the total distance. But since you've ended up back at your starting spot, the displacement from your starting and end position is going to be 0 meters. So yeah, great job, everyone. We're gonna keep moving on then. So moving on to some more values. You'll notice the velocity equation here is going to be extremely similar to that displacement equation you saw earlier, and that's going to hint to how acceleration is basically acceleration and velocity have the same relationship as velocity and displacement. And we do have that the change in velocity is going to be acceleration times change in time. And this is going to be important for a lot of later equations and just basic derivations of all this. So yeah, if you start at 2 meters per second and accelerate by 1 meter per second squared for 2 seconds, obviously the change in velocity is going to be 1 times 2. And what this is going to result in is going to be a change of 2 meters per second, and you add that to the original to get a total velocity, well, not total, final velocity of 4 meters per second. This is going to be it's hard to consider displacement directly given an acceleration, but a few of these later equations we're going to look at are going to help with that a lot. And as far as physics 1 is concerned, most situations you're gonna look at are gonna have constant acceleration. You won't have to like calculate anything without constant acceleration most of the time. You might have to like uh consider things like how far you've traveled compared to something else with a different acceleration, but you won't really have to calculate without constant acceleration most of the time. So don't worry about like accelerations increasing at 2 meters per second. 2 meters per second, actually. Oh yeah, going back to that real quick. Oh shoot, that goes. Wait. Going back to that. This is just something, a fun little thing, fun fact your physics teacher might share with you. You've seen how velocity is changed in displacement, acceleration is change in velocity. After that, a jerk would be considered change in acceleration. At this point, beyond acceleration just goes past the scope of physics one. It's just fun fact after that. But after that, you have jerk, then you have jounce. I think after that, change in jounce would be considered lock. That comes later. You can look stuff on your own. There's just at some point you have snap, crackle, and pop as the actual terms for change in something of position. Which is just kind of funny to think about. It's not exactly relevant to the course, so. Alright, we have about 20 minutes left right now. We're moving. So your physics teachers are definitely going to go over the 4 kinematic equations. And these are going to be 4 equations concerned with the values of displacement, initial velocity, and final velocity, which will be considered separate. Because you're going to have a lot of questions where you have like a ball is rolling at 5 meters per second. If it undergoes an acceleration of 3 meters per second squared for 5 seconds, what's the total displacement? You'll have questions like that show up. So instead of average velocity or change in velocity, you're going to consider initial and final velocity as their own quantities most of the time. And of course, outside of that, you have acceleration and time as your other quantities. And for the situation where you're going to use these kinematic equations, acceleration will always be constant. You will never have to use these outside of constant acceleration situations. Because otherwise you're going to be able to use concepts like energy or momentum, which we'll be going over we won't be going over in this course, but you will go over that in your actual physics course. So as mentioned, there's 4 equations that each use 4 of the 5 values because in the example problem I gave, so you're given initial velocity, then you're given the acceleration, then you're given the time, and then you're told to look for the displacement. That's going to be the standard structure of most kinematics problems, where they give you 3 of these 5 quantities and then ask you to find one of the 4th one of the 2 remaining quantities. And you basically just pick the right equation and then plug in the values and then solve for it. You'll notice there aren't actually 5 equations. That's because there isn't going to be one missing, one without initial velocity. Initial velocity is going to be present in all 4 equations. Because honestly, one of these is going to have all the quantities except final velocity. It's not going to be too different to convert that into final velocity or just convert the information you can. I don't think you're going to run into a question with final velocity and missing initial velocity. That shouldn't be common. Like, it might show up if college board wants to be really weird, but that's not a situation you're going to have to care about most of the time. These 4 kinematics equations should be sufficient for everything. You can technically derive a 5th one. That's missing initial velocity, but honestly, it's probably not worth it. These should be on your like official equation sheet that you get to have during your AP exam. So yeah, your 4 equations to me, displacement is the average of initial and final velocity times time. This is literally just the displacement is average velocity times change in time equation we saw earlier, except with a non-constant velocity. Then you have one that's basically just the change in velocity is equal to acceleration times change in time. And then after that, these next 2 equations are a little more complicated to derive. Your physics teacher will probably go over how to derive these. But the actual method isn't too important for the purposes of the course. I don't think we'll have time to go over the actual derivations. So we'll just read them for now. You'll notice the first one is missing acceleration. The second one is missing displacement. The third one is missing final velocity, and the fourth one is missing time. Out of these, if I had to say which ones were most important, I'd say the second and okay, for most important, I'd say third is going to be the generally most useful, even considering beyond just the course of AP Physics 1 itself. The fourth one shows up a lot on the actual test, just because they like to take away time to make it seem a little more confusing. And at which one you can probably find a way to plug this equation in. The second one isn't going to be directly used as much, but it's just, it's something you should know. And the first one actually doesn't come into play all that much. They don't really just give you those three quantities a lot of the time. But you should still know most of these, if not all of them. Because knowing these four equations basically covers the entirety of unit 1. So that goes forward to sorry about that. That was not supposed to happen. Let me share that again real quick. All right, going out the side. Yeah. The main thing to know about these equations for now is going to just be like vaguely how these quantities of position, velocity, and acceleration interact with each other. And what am I gonna say? Right, so one of the big things people can get confused about in physics is just not knowing the basics well enough, and then getting confused as the course gets into more complicated things. So it's really important to have a solid understanding from the start about how exactly position and velocity are related. Like velocity can be change in position, just like acceleration is change in velocity, and so you can sort of use the comparison. And you can't just skip over like how acceleration affects position, which is why these equations are going to be so important. If you don't understand this early on, this is going to make a lot of the rest of the course more difficult. And obviously, you might be like confused about like how this is still going to be missing courses and stuff. That's going to be coming up in future days. But what's important to note, just like start with very unrealistic situation of like a particle on a line moving with constant acceleration for no reason. And then from there, you can get to more complicated or closer real world or just more physics-like questions that are going to be like, that won't be like as weirdly basic as these ones. So anyway, for now, we probably have enough time to do this short Kahoot there is. I'm going to put the code in chat if Kahoot is willing to let me create it. All right. Yeah, I'll put the pin in chat real quick. Actually, I should just share the Kahoot screen itself. I just remember that's an option. All right, we'll get this started then. I'm not sure if it's going to accidentally prevent me from adding too many people to Scoop, but yeah. This is probably going to be the last thing we do in class. If we have extra time, I'll go over like how to derive the last two kinematics equations. But yeah, sorry about the internet problems today, everyone. The Texas power grid is absolutely phenomenal as always. I just noticed they have a frowny face when you hover over them. That's kind of weird. I'll wait a few minutes to make sure everyone who wants to join can join. let's say there are 27 attendees right now, so there's probably a good number of people here right now. All right, going one, going twice. Yep, okay. I'll just wait a couple more seconds, and we'll get started with this. We'll get started now. There's 16 people here. I don't think I'll quite have a Kahoot for every single day, but there will be one for the first day at least. Yeah, I'll be going over the answers and clarifying if I accidentally clicked the wrong answer in the answer key. So you're gonna notice the question asks for displacement here. So the final position will be 2 meters, but the amount you've actually rolled is going to be, you rolled 4 meters away from your starting point. So the displacement is 4 meters and the final position is 2 meters. That's going to be the key difference here. So yeah, this stuff like this is going to be where a lot of mistakes come up. Make sure you read carefully and make sure you know exactly what you're looking for. Displacement is how far you are from your starting position. It doesn't matter where you started. If I simply didn't include the starting point, the answer would still be 4 meters in this case. Right. Oh, that went too fast. Whoops. Okay, we'll look at the score a little more after. Oh, it's just like one complete circle, by the way. Don't get that confused. All right. Once again, I guess the people can't be determined. This is just one big circle. You do not make like half a circle or just one portion of circle. It's just one big circle of rotation. And once again, displacement is distance from the starting point. If you go in a circle, you end up back where you started. Because that's how circles work. And because that displacement is just going to be 0 here. Of course, in the actual physics exam or any physics test in general, you're going to have a lot more than 20 seconds. If there are future Kahoots, I might increase the time limit on these questions, but yeah, so displacement is being a little tricky for people, I guess. Just be a little careful about what exactly you're looking at. Not because you're not looking at distance in that question. Completely unrelated, but I do have this funny memory of true or false questions showing up multiple times in a row, and then at some point they swap the true and false options, and then it just trolls a lot of people. Anyway, so yeah, the displacement is going to be 0, yes, because velocity is displacement over time. However, just like the previous circle problem, if you roll in one big circle, your total displacement is 0, and your average velocity, therefore, is also going to be 0. But you still rolled, like you have still gone in a full circle, so that you still have traveled distance. Yeah, so the whole difference between velocity and speed and displacement versus distance is something really fundamental that you're gonna have to get down if you want to get a lot of these questions correct, because you're gonna miss a lot of easy questions by accidentally swapping position and displacement in your head or something like that. Those look like more people got this question correct though. 6-point difference there. Interesting. Yeah, so this is gonna be a lot closer to just regular physics questions. Just rolling on the number line, finding quantities related to how you rolled on the number line or what you've done on that number line. Yeah, so this looks like everyone understands how to do the math. Just needs to be a lot more concept-based questions that are messing everyone up. So yeah, you have, if you start at -2 meters and stop at 5 meters, your displacement is going to be 7 meters. And of course, displacement divided by time is going to be 7 divided by 2 is 3.5. When you're doing these types of questions though, remember that you don't have to have traveled in a straight line from start to finish. If you like roll backwards 8 meters and then go forwards 15 meters, that would still be an average velocity of 3.5 here if you do over 2 seconds. That can be a little awkward in some tests. This is going to be like, yeah, for this question, it's going to not just be 1D, just for any case ever. If you have an acceleration like that, what's going to be the final speed here? Right, yeah, so I wonder if the wording might have been a little bad, but I was specifically referring to cases outside of just one-dimensional motion. So like I mentioned earlier, you don't necessarily know what's going to be happening to your velocity as you have acceleration. Because the acceleration, if it's, I probably should have specified direct. The fact here is that I didn't specify direction. So you don't actually know which direction you're accelerating in. If you're accelerating like left while rolling forward, then you start turning left, but at first you don't actually have any change in your speed. So like have a ball rolling right at 1 meter per second and then like apply acceleration into different directions, and you'll see that your final results are going to be a lot different. So like if you have an acceleration, if you're rolling right and you have an acceleration up, then you're going to end with like square root of 17 velocity speed, pointing some direction up and right. I think my wording was a little awkward here, but yeah. Just keep in mind that acceleration doesn't necessarily imply a change in speed. This is going to be especially important in rotation, or not rotation, circular motion, where if you have an object spinning in a circle, you have a constant acceleration with no change in speed. But your velocity is constantly changing because you're turning. Full of really fast answers, then we're not getting any more. See. Right, yeah. Looks like everyone got this one. So the main difference is velocity can be negative. You can be traveling at negative 1 meters per second on a number line, where you're moving backwards at 1 meter per second. Your speed there is still going to be positive 1 meter per second, however. So yeah, that's the main way the values are going to be different. It's just positive or negative. Because the velocity having a direction means you can be traveling opposite of a certain direction, which would be negative, unlike if you your speed cannot care about your direction. Yeah, most people got that. 2 more questions, 3.7. Might have to go a little quicker on these last two. All right. Consider this. If your velocity is negative, but your acceleration is positive, what's happening? So you're rolling backwards, but you're starting to roll in the forwards rush. So if you have if you drop a ball onto a spring, and while the spring is getting pushed down, your velocity is going to be downward, but as the spring's pushing up on the ball, the acceleration is going to be upward, and eventually the ball's going to get pushed back up and away again. So essentially that your actual value of your speed is going to be decreasing while your velocity is negative and your acceleration is positive. So the way to think about this is if the velocity and acceleration are in the same direction, speed is increasing. If they're in opposite directions, then the speed is decreasing. And if they're perpendicular, the speed is not changing. The last case is once again a circular motion thing. So yeah, keep that in mind. Directions are funky. Last question. Almost out of time. Oh, when I say change direction, I basically mean like makes a U-turn, not just like turns sideways or something. That might have tripped a few people instantly. Sorry. This is going to be one-dimensional motion again. Just if you turn around over 4 seconds and continue at the same speed, what's the acceleration? Yeah, sorry, that's definitely that's definitely just on me. I should have specified it a lot better. Good on everyone for like noticing that just because you change direction doesn't mean you know which direction. I probably should have allowed that to count as correct, to be honest. But yeah, in purely terms of just kinematics, what we're looking at here is going to be your final velocity is -5. Your initial velocity was 5. And so that's going to be 10 divided by 4 is going to be 2.5. Technically, it's going to be negative 2.5 if you consider yourself to be moving positive at first, but yeah. Oh yeah, if a question asks directly for the magnitude of a value, just always put the positive version. If a question asks magnitude, just put the positive value. Don't say negative north for magnitude, just say 2.5 or something like that. So yeah, the next teacher should be coming in soon. I'm not sure who decided names of period, but yeah. All right, thank you everyone for coming. Tomorrow my internet is probably going to be here as well as my power in general. I love Texas, but yeah.